This is Mrs. O'Neill for Chapter 2, Section 1, Matter and Energy. Have you ever wondered why the stars shine, or why leaves change color in the fall, or how battery generates electricity? Have you ever wondered why keeping foods cold slows their spoilage, and how our bodies use food to maintain life? Chemistry answers these questions as well as countless others. Chemistry is the study of matter and the changes that matter undergoes. One of the joys of learning chemistry is seeing how chemical principles operate in all aspects of our lives, from everyday activities like cooking dinner to more complex processes like the development of drugs to cure cancer. Chemical principles also operate in the far reaches of our galaxy, as well as within and around us. So this picture in the background here is a picture of the galaxy Omega Nebula. Like I said in class, chem is try. All I'm asking you to do is try chemistry. Not many comics and jokes, but I do try to pull out a few. So this is section 1, properties of matter. It tells you to read these pages, but I'm going to strongly suggest you really only need to read those pages of each section if you're struggling with the bookwork. So when you guys get together and work together and ask me questions, I might say, well, now you might need to read that section or at least that paragraph or two to get a better understanding. But the pages are there that correspond to all sections. You should have watched that intro information and take notes. You should have also focused only on these times, even though it was about a 9.5-minute video. These were the times that you should have actually taken notes on. The other stuff wasn't really important information that you're going to need to know. So what did he talk about? Well, here are my notes, and I'm going to go through them quickly because you should have taken your own. But he talked about matter and its definition. Again, he talked about dark matter, but we're not really interested in that. We are interested in, though, that we can differentiate between pure substances and mixtures. He gave you some examples, and if you also want to look at my flow chart and my examples, because it shows you on that molecular level. He also talked about the abundance of elements. So if you want to pause and look at this periodic table, it shows you the abundance of how much these elements exist in nature. So I thought that was a pretty cool periodic table to share. He talked about atoms and molecules and how they really possess 5 states of matter, but again, the 3 states of matter is what we're going to be interested in, is the solid, liquid, and gas, and they are linked to the kinetic energy, the movement of those molecules. He talked about directly and indirectly measuring matter. So on to your packet of notes for actually section 2.1. The objective for this section is to identify properties as extensive versus intensive. So those are 2 words that might be a little different. You haven't heard those before. So we'll talk about what they mean and give you some examples. You're going to define physical property and list some common properties of substances. You're going to differentiate again, among the 3 states of matter and describe a physical change. The more than 1,200 species of bamboo belong to a family of grasses that includes wheat and corn. In tropical regions, bamboo plants grow rapidly to great heights. The tender shoots of some bamboo plants are a favorite food of pandas. People use the woody stems of mature plants to make furniture, fishing rods, and flooring. Because bamboo is inexpensive and abundant, there's that word abundant, a lot of, that's what that means. Abundant means there's a lot. Disposable chopsticks are usually made from bamboo. Bamboo has properties that make it a good choice for use in chopsticks. It has no noticeable odor. Oh, the smell would be a physical property. It doesn't have a taste. Oh, physical property. It is hard. That's a physical property. It is easy to split. That's a physical property. And it is heat resistant. In other words, it doesn't get hot right away. Like if you were to put a spoon, because spoon is made out of metal, and you would put it on the stove, it would eventually get warm. Even the handle would get warm because the heat would go through it. But chopsticks, you can eat hot things, and the chopstick on the top where you hold it is not going to get warm. In this section, you will learn how properties, and these are all considered physical properties, we're going to talk about chemical properties in the future, can help us classify and identify that matter. So in other words, if we would have a piece of stick and we'd want to know if it's bamboo, well, we would test it for all these things and then decide if it's bamboo or made out of something else. So pause the video, fill in the blanks, and then play to hear my words. So extensive, ladies and gentlemen, is extensive. It's exit, right? Outside, exiting, right? So extensive is the amount of matter, how much there is. So I can have 2 cups of water. I can have a 10-gram cup of water. I can have a 5-gram cup of water. So that's its mass. It's still water, but it's extensive because it's how much you have of it. You could have 5 yards. You could have 10 yards. That's the area. However, intensive is inside. I like to say it depends on that type of matter because it doesn't matter how much sulfur you have. You can have a little bit of sulfur. You can have a whole desert full of sulfur. You're going to end up with that yellow color. It doesn't matter if I have, again, that 5 grams of water or the 10 grams of water. The boiling point is going to be the same. So a substance in my eyes can be identified as an element or a compound. If it's pure element, it's only going to have those atoms of that element. If it's a pure compound, it's going to have only those molecules of that compound. So a substance to me is pure. So an example of an element would be something like carbon and mercury. An example of compounds would be water and salt. So pause the video, read this information, look at the chart, and see if you can answer this question. So which one could not be used to distinguish copper from gold would be the state of matter because they both are solid at room temperature. So you'd be able to differentiate between the two, between their color, and of course if you do some testing between their melting and boiling points. So a physical property, and I want to remind you, read the entire thing as you're writing your notes. Again, a reminder, a physical property is just the characteristic property of that substance. It's its color, it's its melting point, it's its density, it's how hard it is. And all those things it's the physical property because it's kind of like what makes it what it is. So again, pause the video, make sure you're filling in, but these are states of matter and how, depending on the state of matter, how the volume, how the shape, how the particles are held together, and how their movement is. I like to look again at that molecular level. So if we look at a solid here, again, it reviews that chart, but it also shows you on a molecular level that those atoms inside are really closely packed. They're in a specific arrangement. However, in a liquid, you see there's a little bit more space in between those molecules. So it has a little bit more area to move around, and they're kind of like flow past each other freely. And in a gas, however, look at this. You have so much space in between because they are so far apart. Those particles, those atoms or molecules or even mixtures are going to be so far apart from each other that they definitely can move around freely. So in your notes, make sure that you're drawing these things on a molecular level so you understand what I mean by what the atoms look like inside. So again, something cute. So again, I'm going to quickly go through these, but again, these are just visuals. So here we have what the example is and how those atoms, in this case, because it's an element, how those atoms would look in that gas, liquid, or solid phase. This, however, is a compound. This is a compound, a diatomic molecule, and we'll talk about that. But you can see the difference. Hopefully, you can see that there's a blue dot and a red dot connected with each other. So again, as a solid, liquid, gas, how they would look. Here is water, okay, very similar. Here is H2, again, another diatomic element. And here is a mixture of those elements of helium and neon. And there would be a mixture of nitrogen, which is an element, a diatomic element, and water. So again, maybe pause and do a little visual because I know a lot of you guys are visual learners, and these particles are so small I can't show you really what they look like in class. So here's something extra. He did talk about plasma, so if you want to, you can pause and read this information. This is stuff that I found later. As well as Jello. People have asked me about Jello and where would that be classified as a solid, liquid, or a gas. So again, read over this and it's just kind of cute information. So a physical change tells us that we're going to take a physical property and change it. However, the composition of whatever substance we're changing does not change. However, there's two types. There's reversible, and a really, really good example of reversible is melting. So if we take ice and we melt it into water, we can easily take that water and put it back in the freezer and make it ice. So change of state is going to be considered a physical change. Irreversible, however, is like cutting hair. I'm cutting the size of your hair length. However, hair on the floor, when I cut it, is still going to be the hair that came from your head. But it's irreversible because I can't re-glue back that hair. Okay, so hair is still hair, but it's just shortened, right? But we can't glue it back. So those are the difference between reversible and irreversible physical change. So what do you remember? Read, pause, and see if you can come up with an answer, then play to see if you got it correct. Hopefully you got that. And again, these things, if they're not making sense to you and you're still not understanding, please ask me in class. Number 2. Hopefully you got that. Number 3, take a few minutes. And hopefully you got that as an answer. Okay, we'll see you in class.